This is the Average Guy Network, and you have found Cyber Frontiers, show number 45, recorded on June 25th, 2018. Here in Cyber Frontiers, we explore cybersecurity, big data, and the technologies that are shaping the future. If you have questions, comments, or contributions during or after this webcast, you can send us an email. Send it to me, Jim at theaverageguy.tv, although probably better to send it to Christian because he's the mastermind. I don't really know what I'm talking about. You can send it to Christian at theaverageguy.tv. Find me on Twitter at Jay Collison. That's another great way to do it. Or find Christian on Twitter at Borg Whisperer. Of course, theaverageguy.tv platform, both media and web hosting powered by Maple Grove Partners. Get secure, reliable, high-speed hosting from people that you know and you trust. Christian and I was updating a few plugins on the live site just before the show. 3 plugins, 3 seconds. It's literally the fastest thing I've ever seen. I was like, click done, click done, click done. So thank you. Thank you for some great web hosting. By the way, that plan, $10 a site, $10 a month per site. You can get more. You can get all your questions answered out at maplegrovepartners.com. Joining me tonight, Christian Johnson. Christian, we've done 2 in a row, two weeks. We seem to be on schedule. This is awesome.
It's a good omen. We're back to business, right?
Yeah, I kind of like it. I think we'll shoot for every 2 weeks. Mondays seems to be the best night for you. Is that true?
Okay, for sure.
So we will shoot for Monday night. It's not a bad night for me. So we'll continue to shoot for every other Monday night. If you want to join us live, come out 7 or 8 p.m. It kind of just depends on our schedule. 7 or 8 p.m. Central, 8 or 9 p.m. Eastern, out here at theaverageguy.tv/live. All right, Christian. I don't know what's going on in the background. Are they okay?
Yeah, I don't know. We'll find out.
We in the last show we kind of said, hey, it would be great to talk about machine learning and AI. Those seem to be the 2 hottest words in everything. Like, I turn on my smartphone and it's using AI now magically. I don't know how that works, but everybody seems to be claiming AI and machine learning for everything. So we thought we'd dig in a little bit tonight, kind of explain that. What does it mean? What does it not mean? What is it? What isn't it? But we want to start first with a little cyber humor. So you got a little humor for us.
Yeah, so I just feel like, Cyber Frontiers, if there's the word cyber in the show, you always have to have at least one thing cyber. Today's humor comes from Krebs on Security from last week. He did a pretty great write-up about the top most abused top-level domains, and I found it super ironic and humorous that 55% of all registered .men domains are used for malicious purposes. So of the 65,000 or so .men, 36,000 or so are bad domain, are considered bad, whether that be spam or malware or others. I feel like women would largely agree that .men domains are always going to be rated very badly. So this statistical method proved true in more ways than one. But I thought it was pretty interesting because I don't think a lot of people realize just the advent of how much new top-level domains are getting used in general social phishing and engineering techniques, and also for legitimate purposes, right? Like for such a long time, throughout most of the internet's existence up till late 2008 through early 2010, right? Like most of the internet existed in the world of .com, .net, .gov, or .org, right? So the fact that there's now just such a huge advent of random TLDs, the average person might still not necessarily recognize or be aware of all of the new top-level domains that could be showing up in emails as links or legitimate websites or otherwise. So I thought it was just a humorous way to call out how they're being taken advantage of. Of course, one of the ones that made the top 10 was .ml, which I find amusing because I think machine learning immediately. I'm not sure what the actual intent there was, but that's kind of where we're at. So I thought he just does a nice statistical breakdown and correlation of how the top level domains correlate to shady sites or sites that are serving up problems for users. And I think, all in all, we're definitely the total capacity for us to use these names in ways that aren't intended has definitely gone up from, the tens or maybe dozens of top level domains that used to be available to the hundreds that are available today.
Yeah, they do cost a little bit more sometimes to get them. Some of the ones that you mentioned .men already, which I had no idea that was actually a real one. And then .gdn, .work, .click, .loan, .top, .cf. Wonder what that's not Cyber Frontiers. But .gq, that makes sense. There's another man related, that magazine GQ. .ml and .ga, all in the top 10. We've had a link if you want to go out there and take a look at them. They have a badness index. How do you know how they're figuring that out in that link?
I think they're using the Spam House project data set to figure out like what's the percentage of spam or other bad things flowing through this particular top level domain. But they also give a nice link to the ICANN site, which contains the official registry of all the top level domains that are out there. And we're over 1,500, which is crazy considering, several hundred of those have been added in the last few years. But you can see a huge boom of them, obviously, in 2013 when a lot of the floodgates opened up for registering some of these TLDs. So it's pretty interesting to see the companies that show up that are registering them, and also the level of growth that we've had in TLD registrations in the last 5 to 10 years.
Yeah, later down in the article, it says security firm Symantec in March published its own 2018 list of shady TDLs, .country, .stream, .download. You really got to be careful. I think, especially as you see these things in emails, right? I'm sure there is a ton of phishing going on with each of these trying to direct you back to something, right?
Yeah, for sure. Especially when you can get the same exact name as the .com equivalent with the exception of a different TLD. Some people might not immediately pick up on that right away when they're quickly looking and clicking through to something. So it's pretty effective from that perspective.
Yeah, especially if you take a known domain and then maybe put a .bid or a .ren or a something you might see, or a .stream, like you might see download .stream.
Right.
And you think, oh, they're just using a CDN, right, or something along those lines, or even a .country, which you might equate with a dot a .org or something along those lines. We think, well, it's a .country, so it says something like Germany .country, and you're like, okay, this is probably okay. When it's probably not. That has a pretty high percentage of shady sites associated with them. That's there. So something I think you definitely want to watch out for, and something that's not the easiest thing in the world to detect. Christian, any advice for folks when you're thinking about seeing these and they show up in an email or they show up somewhere else? Any advice for avoidance? Just don't click it. Is it that easy?
Yeah, just don't click it. Click what you know and recognize. If it's anything that's not ending in .com or .gov, I'm usually I will like review the full URL. The other thing to keep in mind though is that there's still always the opportunity for someone to hijack a open redirector or otherwise through legitimate domains. So while it's increasingly less likely to see it in very common domain names like paypal.com, you're not going to see that kind of thing with, but kind of do the first sanity check of, hey, does this thing end in a .com or a .gov? Is it something that I know I use frequently? A lot of times the easiest way to know something is phishing is when you get an email for a service that you've never signed up for before, and you immediately go, oh, obviously that can't be real, right? But how do you protect yourself from when it is a service that you use? And really breaking down the link pieces and making sure that you're clicking something valid is good to keep in mind.
Ross makes a good point in the chat room. He says he bought a bunch of newer domains, not the ones that people are using for this notorious stuff. But ultimately, I think people still like to see .com and then maybe .net or a .live or .tv. Of course, we're the average guy .tv. TV does not stand for television, right? It's for a country. And so I think he's right. Christian, inside of Skype, there's actually a Skype bot called Security Bot by Metacert. And you could copy and paste that link. So if you you kind of had some questions like, is this a site that I can trust? You can copy and paste the link into the bot in Skype, and it will send it off, and then it will come back with a message after a short period of time and tell you whether the site is good or not. So that's kind of a nice way, if you're in Skype all the time, kind of a nice way to check the site. Do you know of any other services like that where I could copy and paste the link in? It would kind of tell me without having to execute it in a browser.
There are a lot of websites where you can basically get a snapshot of what the browser looks like when you put the link in. I think Browser Shots is one of them, where you can just drop the link in and it'll hit it against a set of different browser versions and give you back the page. That kind of service is used more for actually testing like browser cross compatibility with your site, but there are a lot of websites that I can include in the show notes if we want, that just rattle off whether or not it's a known blacklist or not. But if you actually want to see it, yeah, use something like Browser Shots, because then you'll easily get a screenshot without actually having to visit it.
Yeah, you definitely don't want to execute it in a browser if you don't have to. And of course, using a bot in Skype, you're not necessarily they're sending it off for you in some kind of isolated, some kind of isolated container for both them and you. So those things. If you've got more suggestions, other sites that check that stuff for you, we'd love to hear about them. Send us an email, jim@theaverageguy.tv, and we'll include those in maybe the next conversation. Christian, I've been joking recently that anytime anybody writes a computer program these days, it's AI or machine learning. Everything seems to be like I wrote a program, it returned a result. Oh, that's AI, seemingly. So we wanted to debunk that a little bit tonight, because it's not, and there's a lot more to AI. So as we think about AI and machine learning, not only is it not, I think, what we think it is, but there's a difference between the two. We use those two terms together a lot. A lot of companies are using it in their marketing materials. Oh, we use machine learning and AI, or we use AI and machine learning. So let's dig in a little bit. Where do you want to start us when we think about what is this, and what's the difference?
Yeah, I think I actually want to start talking about it by taking us back 3 to 5 years to see what the equivalent storyline was that built out prior to us getting here, right? So it's really hard to talk about AI and ML without first talking about what were the buzzwords of the past 5 years, and how did those buzzwords lead up to where we got today. And I used to famously joke with anyone that if you wanted to guarantee yourself to getting to an on-site job interview as a computer scientist, in any major company in the 2010 era, all you had to do is write the word Hadoop on a resume, say the word Hadoop in a meeting. You could know absolutely nothing about it, but people were so desperate to wrap their heads around what was the technology incubation and progress that was being made in distributed file systems, data science, and just loosely speaking, big data. What was that? And so companies really were looking for folks who were really good at, I think, what ultimately distills as data science, but also high performance computing, right? So with the advent of Hadoop, we got several capabilities that really brought us into an era of quote unquote big data. And I'm not saying Hadoop specifically was what did that. I'm saying it was one of several major enablers. But I like to use the Hadoop example because I remember all the tech meetups and tech talks and demos and user groups and job interviewing fairs and otherwise, where this was the hot topic back in 2010. And from 2010 to like 2016, tremendous amounts of things happened with this. I mean, we've seen entire companies spring up from the advent of using these technologies, but we've also seen how traditional conventional companies took advantage of these technologies. But some of the things that Hadoop really gifted us, or just the generic framework of those technologies gifted us, were twofold. One is this concept of distributed file systems, basically having data that's automatically being replicated and distributed to multiple nodes across network, where data can move either locally on the network rack to a set of data nodes for processing, for disaster recovery and resiliency, and for data integrity, as well as for performance. And that file system and infrastructure really gave us a way to store arbitrary objects onto a file system, in a distributed, fault resilient manner so that we could build data sets that were larger than what a human would be able to process or what a traditional relational database would be able to process, and really just let's throw as much data at the wall as possible and store it in a place where it can easily be read back, parallelized, etc. The second really big thing we got out of big data was this concept of MapReduce and MapReduce like algorithms, which is really the first approach, first stab at how to write algorithms for the world of data science, right? So the famous concept of mapping and reducing is that you basically map a bunch of keys that reference primary keys within a set of arbitrary objects, and then you reduce them to their likely pairs, and you build a sequence of MapReduce jobs in such a way that something that ordinarily would be not very feasible to do in a relational database, you could do at scale in seconds in a non-relational data model. And so kind of classic approaches in MapReduce like algorithms were very useful. Why? Because one of the most fundamental data structures in computer science is a map, or, like in Java, it would be a hash map, right? So just having arbitrary key and value pairs, one of the most fundamental concepts we've had in computer science for a long time. MapReduce specifically gave us a high performance computing way of thinking about MapReduce like problems. One of the most famous map data structure problems that any computer scientist would study being word count, right? I give you a dictionary, you tell me the list of the most frequent words that you found in this book. You can define some filter words that exclude certain phrases or words. And then you can do this analysis of, I think this page is talking about these types of entities based on the most frequent words that I saw in the page. Very naive, but very effective approach. Whereas the equivalent thing not done through a distributed file system would be slower, as we're talking about millions of pages of text to be analyzed, right? Then machine learning I keep jumping ahead of myself already. Data science, big data really expanded to, let's not just do MapReduce, let's do streaming analytics. So you saw things like Apache Spark come out. Let's not only do streaming, but let's get way better at how we think about doing ETL and transforming non-obvious data structures and data types into things that are easily malleable, easily reproducible, et cetera, et cetera. And we got to this point where we could build commodity hardware, we could store data at petabyte scale very easily, and we could write interesting software frameworks and platforms to manipulate that data and have it do its bidding for us. And really, it was when we took the handcuffs off of using the traditional Oracle systems and large relational database systems that have been dominant in business-driven logic and applications for decades. Once that framework got laid out and really has been matured over the last 3 to 5 years, we were then able as an industry to start talking about machine learning, which really got us to a place where, hey, it's not enough just to be able to store data, retrieve it easily, and do these types of interesting analytics. We need a general purpose model that allows us to take advantage of all the rich data that we as businesses, as entities, and otherwise have in order to really drive value and new insights from things that we're not telling the computer to do and look at. And so when machine learning got popular and really started to take foot, I always tell people that machine learning in many respects, whether it's supervised or unsupervised, boils down to magical statistics, right? We're applying advanced statistical or other mathematical techniques that allow us to create general purpose solutions for a quote unquote machine to learn specific elements of information or data by being trained or seeing things over time and making adjustments, right? But it was the first time that we really, as industry, as academia or otherwise, got to the point where we were generalizing the use case for saying, hey, our analytics no longer should just be business driven code with if and else ladders and specific logic criteria for making this happen if this other condition is met. No, we really said, hey, machine learning, take a look at all of our data, apply a general principle by which you will analyze and try and make sense of what this data means to you, and then make the prediction or make the thing that allows us to classify, label, and make determinations about future data that we're giving the machine. So really, the order and sequence by which the buzzwords came out, it was really kind of big data in the Hadoop era first. Then it was machine learning. And somewhere in between the time where machine learning was the hot thing and using the word big data became lesser so, we have not even gotten to a separate parallel thread running, which is Internet of Things, right? People got really obsessive with Internet of Things, probably starting late 2014 through 2017, right? So like a little bit of an overlapping timeline here, right? We have big data and data science kind of ranging from that 2010 to 2015 mark. We have Internet of Things running from like 2013 to 2017 as its introductory fare. And then we have machine learning kind of becoming popular from 2016 to present, right? So let's talk a little bit about Internet of Things first. One of the big things that advented Internet of Things that we've talked about in the show a lot is IPv6. Every device, every network in the world is hyper connected to one another. There are sensors, there are gadgets, they are just integrated naturally into the fabric of our daily lives. And IPv6 became an enabler for Internet of Things because it allows every single device, whether it's your refrigerator, your watch, or a non-traditional device, to have its own IP address, its own way of communication, and its own ability to push data, right? Stream data, stream metrics, tell us what's going on with it, make inferences about it. And so one of the tenets of having successful machine learning is that A, you have a large enough sample size, B, that you can train on and have the algorithm learn over time. B is that you have a large enough data set to actually process through so that your machine is actually telling you things that you yourself don't know or can't determine. And so Internet of Things is an enabler for that data to exist. It is a very pervasive, autonomous, very hands-free administration model for us to get gobs and gobs of streaming analytics and streaming data on all sorts of systems, whether talking power, internet, the lighting in your house, heating, refrigeration, sensors in an electrical grid. I mean, the use cases are literally endless, right? But now we have this place where sensory inputs are really a way for machine learning algorithms to get additional inputs to become smarter and smarter over time, right? So one of the final big enablers to machine learning being able to happen is, hey, not only do we have the infrastructure to do this, things like distributed file systems and NoSQL and et cetera, not only do we have the algorithms to do this, we can extract, transform, and load data, we can manipulate it, we can write algorithms about it. Our algorithms now move to our data instead of the data moving to the algorithm. And now, oh, by the way, we have all these gadgets sending you more and more data all the time. Now we can really get to machine learning being the new buzzword, because all of a sudden corporations and businesses and otherwise have a ton of data that they don't know what to do with. It's coming from a bunch of devices that they've bought and purchased and are using to enable their business. And machine learning is there to kind of distill signal from noise and provide a new level of understanding that isn't intuitive or isn't obvious to the human at first breath. So those are kind of the three of the four buzzwords, right? In order to put this into context, I'll introduce the fourth term and then we can go back and dissect this a little bit more. So after you get to machine learning, AI has come up. And the thing that's really interesting about AI is that the timeline is much broader than any of the buzzwords that we've talked about. AI has actually been talked to and referenced in literature as early as the dawn of computing itself, because people saw computers and coding and machining as essentially codifying human brain elements, the ability to think, the ability to do actions and have capability. People have been postulating about what artificial intelligence means as early as we've been doing computing, because the whole point of computing in many respects was to replace the job of a human doing something manually. What AI means today is obviously fundamentally evolved from what it meant back then. However, many of the same core tenets hold true, which is that artificial intelligence kind of takes form in two different ways. There's broad artificial intelligence and there's narrow artificial intelligence. And with narrow artificial intelligence, we're really trying to crystallize and do a very specific task extremely well with extreme domain knowledge and very effective high accuracy reproducibility, right? So the use case is something like, I want to be really good at driving a car. I want to be really good at finding grammatical mistakes in an English paper. I want to be really good at understanding when a business process is not at its peak utilization and what things I can change to make that more efficient. So AI is looking at a very narrow use case of like, I do this one thing and I do it really well. That's narrow AI. Broad purpose AI is this idea that the artificial intelligence is modeled after how humans think out of generic processes of computation, and really saying, here's a generic way of thinking about the universe. Here's some data. Go look at it and learn from it over time and be able to do tasks that are basically do multitasking, right? How does the robot respond to this? How does the robot respond to that? And so the artificial intelligence is supposed to have domain expertise in more than one area, and it's supposed to use general purpose techniques to get to that aim. What we're seeing today is that machine learning has really just become a mechanism to satisfy artificial intelligence, and specifically this concept of, whether it's, in my opinion, whether it's general or narrow, machine learning can be used to satisfy the concept of either I want to build a learning model that does this one thing really well, or I want to build a learning model where the system takes a bunch of inputs and learns over time and tries to figure out what's going on. And one of the classic examples in machine learning of a machine learning algorithm that tried to model the human brain was neural networks, right? It was the hot, sexy buzzword of machine learning algorithms when ML first got popular for the masses. This concept that neurons fire and there's nodes and they kind of model synapses in your brain. And the whole idea was, let's come up with a mathematical general purpose way of trying to look at data and come out with results in a way that a human brain might. Now, it's a totally contrived and naive example. It obviously doesn't capture even a small fraction of how the brain does that type of thinking, but it gets us to this point where machine learning is becoming a contract vehicle to satisfy doing artificial intelligence applications. And so this finally allows us to answer the question of, why are so many companies using machine learning and artificial intelligence vocabulary in a vacuum? And the answer is really that, one, machine learning is a vehicle that can help us satisfy and achieve artificial intelligence goals. Two, when you look at the output of ML, it's really allowing us to do capabilities that we've always wanted to do in artificial intelligence long before the field and study of machine learning really took hold and took fruition. And ultimately, there is nothing to say that artificial intelligence must be satisfied by machine learning. In fact, machine learning is a subset field to the larger field of artificial intelligence. So it would be an inaccurate description to say that artificial intelligence is only achievable by applying machine learning based methods. Now, predominantly, a lot of the stuff you see today is based off of those methods, but that does not mean that something else couldn't come along, for example, and totally change the way that we think about doing artificial intelligence, right? So at least as an approximation for how businesses and how the average consumer wants to use these technologies, machine learning is the most effective way to go about implementing AI. I think people want to know, like, what does AI mean as an average consumer? It's things like, "Hey Siri" on your phone, right? Siri taking millions of inputs of how people speak, learning specific domain expertise about the human voice, how the voice modulates, how we enunciate and dictate words. Then it has to have expertise on how to translate the words that it heard and understood into what is it that you want this thing to do, and then actually provide information and outputs that are relevant to you as the person asking it, right? So there's a lot of things going on there. I'm sure Siri is not all machine learning, all quote unquote AI application based. Of course, there's still going to be business driven logic, right? But now we're starting to see a lot of applications and use cases where the really popular technologies like voice remotes, voice control, question answer, self-driving cars, autonomous vehicles, all these things rely on building essentially very sophisticated machine learning models and getting data inputs and feedback loops from the millions of customers that these companies get through their products in order to basically derive self-improving, continuous learning, quote unquote, artificial intelligence.
Christian, the machine does a lot of what our brain is doing. A lot, not everything. I mean, we still have a ways to go to
Almost nothing.
yeah, to get to that. Why does the brain work so well at such a low? I mean, think about this. It's a relatively low power consumption in the calories that we burn. Sometimes I wish my brain would burn a few more calories so I could lose some weight, but it doesn't. In machines, they're burning enormous amounts of wattage in this case. That would be hard to calculate the difference between calories and watts. But let's just, for example, I think we know it's burning, most computers burn way more in watts than we would burn in calories. Why does the brain work so well? And yet we still struggle to get machines to do some of the same things our brains do. We're not that complicated. I mean, the brain is complicated, yes, but I don't think it's that complicated. I don't know. What do you know?
So, easiest answer from a movie reference is I am carbon and you are silicon, right? So, the actual ways in which we translate energy are very different, right? When we're talking about silicon inputs, we are translating an electrical signal into the zeros and ones and the things that actually power the device, move current, etc. And that's a very physics. That's very much the world of physics, transistors, chemical energy, etc. When we look at the human body, it's very different physiological power mechanisms, energy mechanisms. Like I power up my brain by going and eating a burger at Shake Shack. It's a great place. You should
That's
try
a
that
great
sometime.
reference, by the way. I was hoping you'd say Shake Shack.
Yeah. And my computer gets it from maybe a water dam, maybe from burning natural gas, et cetera. So just on a very broad scale, the energy inputs are totally different. Where computers excel really well at as memory recall, very, very precision mathematics in a way that our brain doesn't do it does it, but not very easily at scale, right? So like I can tell you 8 times 8 is 64, and you're going to look at me and almost immediately know, yes, of course, right? But then if I tell you what's 8 times 132 divided by 4 mod 2, you're going to say, excuse me, I'm going to bed. So that's where the computer very quickly outpaces human capacity in memory, recall, and computation.
Yeah.
But those are the things that are its superpowers, and for us are just standard of fare. Whereas where the computer doesn't have superpowers that we do is relating disjoint facts into a cohesive model, having a conscious, which in and of itself is something that we've never been able to produce in artificial intelligence, right? Like the holy grail of artificial intelligence is that the computer is self-aware. Because if you have self-awareness, you have the core thing that makes humans humans in essence, right? Like if you think about animals and the animal kingdom, right? I believe most animals have self-awareness. Most mammals have self-awareness. Humans have self-awareness. Computers do not. difference that separates animals from humans is not only self-awareness, but a consciousness that allows us to understand things like morality, ethics, communication, like higher order thinking. And so that necessarily is not found or reproducible in non-human species. So we're not even there yet, right? We're at the point where it's like we are so far off the mark in computer science from having computers be self-aware. Computers are only self-aware to the extent that we provide business-driven logic for them to know who they are, what they're doing, and why they care. And if it's a fundamental problem in biology and chemistry and psychology as to how we understand our own human consciousness and self-awareness, you can imagine how much just as hard, if not harder, it is in computer science to be able to replicate something that we still don't understand biologically, right? So first thing going in is just that artificial intelligence holy grail for a long time has been, if you can get a computer to be self-aware in addition to it being able to learn over time, maybe it'll have the ability to relate the disjoint facts that we as humans naturally get as we learn and mature our skill craft. With computers, we've gotten them to a point with machine learning where we can apply mathematical models that take advantage of the computer's ability to do computation better than humans in order for them to fake it until they make it when it comes to learning a general purpose model and giving you outputs that are not specific business logic code, but are actually based on statistical patterns, finding anomalies in the data, looking at a much larger data set in parallel than a human brain could, and then distilling data for us, right? Those are things that humans cannot do. And so therefore, computers look really smart or artificially intelligent because they do things that we aspire to but can't quite get there, in a very specific domain. Whereas, we're still able to learn and explore in very disjoint areas of the world and are self-driven, right? So we are self-motivated individuals. Our programming is a byproduct of things like our environment, our own free will, et cetera, et cetera. And so if you cannot give a computer some of those, I know I'm getting a little meta here, but if you cannot give computers some of those same fundamental characteristics, it's very hard to ever say you'll be able to get a computer to think like the human brain, because inherently humans think from a chemical and emotional place as much as they do as a logical and structured place. And with computers, we're very good at logical and structural constructs, but we rely on the humans to provide the kind of the plugging of disjoint things in order to make the magic happen.
I didn't know that's what you were doing with that. So you have to watch the video.
I think of this as plugging in two large wires and watching the fireworks light up or the Christmas tree turn on.
Well, I think one of the disadvantages to machines is they don't have a will to survive. Certainly, millions, billions, potentially for life, for carbon-based forms. Is they've had to do certain things to survive, like to make it. It's programmed into us, and so machines don't make those, or they don't have to make those kinds of decisions to continue to propagate, right? And I think that's one of those things that we miss. Maybe we'll spend a whole show talking about the ethics, the mechanics behind artificial, when we think about creating life with a silicon-based form. Man, I think there's some interesting things in there. We are seeing, one of the things a machine isn't, or traditionally hasn't done very well, that's getting better at, is this idea of spatial and understanding where it's at and what's around it, and not just physically where it's at in a room, but what kind of obstacles exist. How do I get from A to B? Why do I want to go from A to B? Some of those kinds of things. We've seen some pretty interesting videos coming from Boston Dynamics. They seem to be the ones out ahead of having, these machines that look like four-legged mammals who have this incredible balance and some of those kinds of things. Why is that spatial directional, this idea we move, although children, when you have a baby, it takes them 3 or 4 years to figure this out, right? Why are we so good at that and machines are so bad?
Yeah. So actually, one of the things that I think people really have always been alarmed and fascinated by Boston Dynamics is that so spatial intelligence in general is one of the, like, I think there are 7 defined domains of intelligence of the human mind, and spatial is one of them, right? So like, how good are you at knowing the difference between if you're pointing north or pointing south, or if I dropped you off in the middle of a maze, how quickly would you get out? Or if I was lost in a forest, like your sense of direction and spatial ability and spatial awareness is actually one of the 7 categories of human intellect. And um, Boston Dynamics is really the first company that just shows how impressively far we can take the extremes of knowing the domains and the limits that we have in artificial intelligence and machine learning, how we can push the superpowers that I talked about to their extremes for AI in order to replicate that thing that looks so much better than what humans can do, or just like what humans can do, without thinking or going about it in the same way that humans do. And so, you know, the Boston Dynamic robots have always been really impressive because, you know, you can kick these things over, they can run up mountains, they have a very great sense of direction, they understand terrain very well, they understand how to take on load, they have a lot of visual and sensory inputs. Like I said, just like I said earlier, how Internet of Things was an enabler for machine learning. Well, all the little sensors and gadgets that make up these robots become sensory input that allows the data model to become more sophisticated. And the more sophisticated the data model becomes, the more precise and elegant the solution space is. And so, um, you know, I think when people see the personification of these robots, the fact that they look like them, they have 2 arms, 2 legs, they pick things up the same way, they walk the same way. If you kick them and they fall over, they get back up. People look at that and they have an emotional response, which is, wow, that's exactly how I do it. And they think, gosh, we're about to live in Skynet and be run by robots the next day. And that's really not true. Like when you look at where we are with these types of systems today, um, it's amazing. Like a very well trained eye can look at some of these videos and some of the things that are, you know, in the post credits of the demos, and see where things go disastrously wrong and making a mistake in the data model. And the tie back to cybersecurity here is, of course, that a lot of these solutions are only as good as their data inputs. So the next frontier of security, I'm convinced, is going to be people continuing to muck with data inputs such that they can coerce the outcome of artificial intelligence and learning algorithms to be something that it's not supposed to be. Um, that being said, Boston Dynamics is a great example of where it's a kind of a subset of the whole self-driving car thing, which I think people accept as being, you know, kind of starting to move out of prototype and getting into like some real test cases and like, hey, are we actually going to do this thing for real? But these robots that can pick up and move and walk around like we do and have sophisticated applications, that's kind of the next evolution of spatial awareness to a spatial domain that we already solved really well, which was self-driving cars. So it doesn't surprise me that we are at that point. Now, just like Internet of Things, one of the prerequisites is that we now have billions of devices that are quote unquote IoT. Um, and that, think about just in like the last 10 to 15 years, how many cell phones, gadgets, sensors, etc., IoT, whatever, has shown up. That's just been in the last 20 years. I predict, worth the price that you paid for it, which is free, that we are going to be seeing a very similar trend with robots. Everyone's going to have their own pet robot within 20 and 30 years. Now, what the capabilities of those robots are, hell if I know, right? Like we've seen some really great stuff with IBM Watson being able to be as smart as a second year med student. We've seen some really great domain applications with, you know, what you see with Boston Dynamics, et cetera. We've seen a lot of business driven applications. So if I, you know, took a Boston Dynamics humanoid robot and gave it the brain of IBM Watson, and I don't know, attached to that some savvy data models about common day problems that you see, could I have a pretty decent personal assistant that is not a half bad companion to solve and do basic tasks? Sure. Is that thing going to kill me in my sleep or do something strange? Probably not yet. But we're getting to this place where, because we've solved very specific problems so well in very narrow domains, the way to achieve general purpose AI, I think, within the short term goal, is going to be to concatenate or join together these disjoint domain expertise areas that we've built up over time to come up with more general available robots that do broader tasking and have a broader mandate. And eventually, when we get really, really good at doing that, that's where the danger will start to assert in, right? And the fear that someone codifies that if you recognize a human in your sensory input, then shoot to kill. But keep in mind again that these machines are only as good as their programming right now. So until we get to a point where maybe not even necessarily self-awareness takes place, but we have a lot of really good code be coerced or used, or the wrong data inputs come in, yeah, maybe it does something that you don't expect. But it's really hard to see in the next 10 to 20 years us getting to that point of dilemma of like, I need to be worried about, the next Skynet like thing, right? Like, we're at a point still where it's very easy to pull the plug on this. It's very easy to coerce the data, make the robot fail, have it fail in tons of ways, right? There's a lot more rainy day scenarios right now with AI than there is sunshiny rainbows. But now when we talk about 70 to 100 years out, where we've put together a kind of suite of really good domain capabilities and kind of codified it together into one offering, yeah, maybe some of those concerns do start to get more real. But for now, we're still in a pretty primitive place when it comes to what the capabilities of this AI is. And really, the mathematics will need to continue to become more complex. We'll need to continue to be able to have information kind of become more mesh and uniform and decentralized and available to more devices. But AI will get to a point where, because of these three pillars, big data and HPC, Internet of Things, and machine learning, we now have a lot larger toolkit than even we did 5 years ago to now start tackling new problems in the AI space that we were not comfortable tackling before. And so this could very much be an enabler for us tackling other domains of human intellect and expertise where we're not necessarily self-aware or self-conscious, robots, but they get to that point of almost magical like quality where, because they have those high concentrations of domain expertise, they will be able to start fooling humans as being as good as they are in some areas.
Yeah, I do think two things we're missing. I mentioned one, that machines don't have today. They don't have a sense of survival, right? In other words, they don't care. They live or die. They shut down or die. They don't care. There's no mechanism built into them. What has allowed living beings to continue to grow and evolve is this idea of survival, right? I need to live to be able to pass on what I've learned to the next generation, so to speak. And then two, machines have no concept of pain. And pain is an incredible learning. Think about machine learning. When they figure out how to program pain and where the machine learns to avoid that, I think there's some things that it will pick up on. Today, again, if it makes a mistake, it's not a big deal. So there's no incentive for the machine to make good or bad decisions. Again, its life is not at stake. You think about a self-driving car, you want a really safe car. You probably want a car that cares whether it's going to live or die through and that has all its own ethical implications. Maybe we can talk about that some more in another show. Christian, when we think about some tools, so let's come back to the present as we think about what's available for AI and machine learning today. What are some of the tools that are out there that folks are looking at?
Yeah, so there's a lot of stuff out there that people can kind of jump in to get started with playing with a lot of this stuff for, more basic day-to-day use cases and to drive needs in their organization or their business. Obviously, the cloud platforms are a great place to start. Pick your cloud platform of choice, whether it's your Google, Amazon, Microsoft, HP, whatever. They each have their own kind of cloud offerings for going and playing with machine learning, and they have sample data sets. They have sample algorithms that you can apply. You don't even necessarily need to be savvy on how to develop the algorithms, how to it helps walk you through a lot of the traditional problems that have made people discouraged from doing their own machine learning. And so one of the links that you'll see in the show notes for this podcast are top 22 tools and frameworks from Computer World on um, enablers for you going and pursuing your own data science and machine learning use cases. And there's even some really interesting libraries, obviously, for your programming languages, whether it's .NET or Python or et cetera. It kind of gives you the best applications for each of those. But then if you're not really a coder or developer, but you still want to start harnessing the power of these technologies, you can get into the big cloud offerings and start playing with data and just going in through the web and learning more about it so that you can put together some interesting use cases and applications to take your business to the next level.
Christian, if we wanted to think about an application that's doing this today, a common app that's out there, something that folks could kind of look at and say, where could I, kind of see machine learning in action? Where would we go? What do you think?
Yeah, so I mean, there's a lot of open source stuff, obviously, whether it's GitHub or looking at some of the open source libraries like scikit-learn and a lot of the Python stuff. If you look up those types of keywords, you'll rapidly find a lot of blogs and readmes on general purpose things that you can download and try out and get with. But it's important to realize that these very common applications you are probably using without even realizing it in today's business world. Like we talked about how Siri and other types of common voice things like Alexa, Siri, Google Home, etc. They all have their own ML and AI at play. But one that I found that was really fun is Adobe is now using machine learning to spot when an image has been photoshopped, right? Which is actually both an interesting data science and cybersecurity problem because with photoshopping stuff, like cybersecurity has this concept of non-repudiation and being able to attribute something to a particular actor, right? And so this idea of knowing or not knowing when a photo has been photoshopped or altered in a way that you can't rely on it is both an interesting cybersecurity problem that is solved by using artificial intelligence. And so, again, there's that AI buzzword, but they specifically use a mechanism within computer vision. And, computer vision is a whole subset of AI that we just talked about when it comes to spatial awareness, et cetera, that is a very characteristic AI. Now you are seeing a common example where something that has nothing to do with moving parts like a car can take advantage of spatial intelligence for a very different application. And so the research paper that they published showed how machine learning can be used to, quote, identify 3 common types of image manipulation: splicing, where 2 parts of different images are combined; cloning, where objects within an image are copy and pasted; and removal, when an object is edited out altogether. That's like a pretty sophisticated capability because unless a human is paying really close attention, they might miss that. Whereas a computer can easily be on the lookout for that kind of thing at scale at any time.
Yeah, we certainly have not been trained to in nature we spot changes of things that don't work out very, that aren't right. We kind of know, humans kind of know that when they're looking at something in nature and it just doesn't fit right, we're able to kind of spot that. Certainly technology has changed where we cannot see to the pixel level where a machine can, right? It can run that analysis so quickly, looking down to the pixel to determine consistency in pixels. Is in this environment, we would expect this kind of image, and it's not there, right? Based on experience, where it can remember all of those. One of the areas where Adobe is working with law enforcement is in helping find missing children. We struggle in a single human would struggle in that space to remember that many faces. That's a perfect application for a database application, so to speak, to be able to compare that and compare it very, very quickly. And again, get down to similarities. It's hilarious. We saw some early versions of this in Microsoft with their Photos app, and they were trying to group pictures for you based on facial recognition. And my kids would always show up, especially my son Tim, would always show up as me, and it would fly. Hey, is this you? And no, it's my son Tim. We look a lot alike in pictures. My son Phil and my son Tim do as well, and so it struggled in those early days. This was maybe a decade ago now. It struggled to find those things, but I think some great applications when we think about, and I see this as being more machine learning than I see it being necessarily AI, right? Of being able to do very fast facial recognition and say now, and this is a scenario. I forget the name of that television show where that guy was harnessing all the cameras and he could kind of watch everybody from everywhere, and the machines were helping him. Person of Interest, was that the one, or
That's right.
something like that? And you go, oh, that would be great if we could have a machine that would help us fight crime with that. And then you think, oh crap, we have to have cameras everywhere. And there's people who have problems with that. You talked about the Internet of Things, what Microsoft calls the intelligent edge now, which I think is a great name. They haven't come up with a lot of great names, but this idea of the intelligent edge, I think, is really, really good in this. But what could be used for good is also can be turned into evil. And, having cameras everywhere harnessed could reduce crime, help us find those missing children. So those things would be great. And yet it all invades in our privacy, right? And so we struggle with some of those things that could be great, but for these reasons, maybe can't be. But I think a great application, when you think about things we have to think about and the processing power that we have now to be able to do those things, pretty powerful, right?
Mm-hmm. Yeah, no, I totally agree. And I think we're going to move to a place where, because of some of the enablers we talked about, all it's going to take is for another one or two big enablers to take place in parallel with the stuff that's already maturing for this stuff to spark to a new level of capability as well.
A new jump, an evolutionary jump. What do you think, if you were to take a guess at the next big thing when in this space, and what you're kind of hoping for, maybe? What do you think that'd be, Christian?
I think it's going to be one of those things where there's going to be evolutions for good and for evil. I think we're seeing, I think self-driving cars is going to be out the gate within 5 years. I think we're going to see really advanced voice control and automation in the home, way more so than we're seeing now. Now we're seeing it come into our TVs, into our remotes, not just our music. Obviously with the smart home stuff, having that voice controlled, all that stuff is going to be there within 5 years as well.
But a perfect application, voice recognition, with all the data we have coming in now, with the millions of people. This wasn't possible before because we didn't have people talking to devices before. Right. And now you think of companies like Amazon who are collecting some of that data, however that works with the terms of services they have. And I don't know what they're taking and what they're not, but you think there's we are now talking to our devices. That is the definition of machine learning. It can be getting improved just after trial and error. What have we learned? Trial and error. Is this working? Right.
Right. Yeah, no, I think so. Obviously though, some algorithms and systems are more responsive to learning from their mistakes than others. And I think as we continue to push for more systems to advance that capability and adopt it, the more advanced the general purpose capability will be as well. But, I only really talked about some of the things that are in that short term. The longer term, and, I'm going to try to avoid X-rated stuff on this show, but sex robots are becoming a big industry for potential evil, in my opinion, where it just could go disastrously wrong and beyond what I think people think they're getting out of that. And when we talk about how humans just reacted to how similar Boston Dynamic robots looked and interacted to them, Imagine when it's in a very like personal and intimate area of your life. That's going to be a weird can of worms for society to figure out. I'm going to leave it at that. Um, but also in general, I think the personal assistant's going to be a hot thing in the next 20 years. Like I think we we see it today in productized forms, right? Like Siri is our personal assistant or Cortana is, but they're these very removed apps on our computer or things that we talk into our phone, and they don't feel very intimate. They don't feel very interactive. When I have that interactive "Hey Sally" standing in my room and having a conversation with me and giving information or assisting with tasks, that is going to be a huge deal. And I don't think we're very far off from it based on what we're currently seeing, number one, and also based on where some of the really common use cases are. Like one of them is, in my opinion, elderly care, hospice care, and nursing homes, right? Um, Having the ability for robots to augment and help folks who otherwise are maybe living at home on their own but need help doing tasks. Like I can't lift up that 50-pound box, but hey, you Boston Dynamics robot can. And if I can tell you where it goes and you're smart enough to understand it, like, wow, you just did something that I wouldn't have been able to do on my own and no one else around is able to do. Like that's a game changer when we talk about improving how humans live, right? Where we go from that, I think like I'm very much set on the 20-year goal being some kind of advanced personal assistant. Where we go from there, I think could diverge in wildly different directions. So it's a little hard to say yet.
Yeah, it's interesting. We're in an interesting intersection. I think maybe every generation. I think the folks in the '80s thought, oh, when the personal computer came out, this is interesting. And then in the '90s, as we thought about more surveillance coming
Right.
out in 2000, as we really that decade is the decade of the drone. Surveillance and the drone. We were able to get cameras on drones, have drones do some amazing things for us, have by the end of the decade have drones fighting the battle for us. I mean, very rarely now are we actually sending actual troops on the ground into things. Many of our battles are just drone battles, as we take care of business that way. Um, and so, as we think about certainly this decade from 2010 to now, this idea of AI, self-driving cars, right? I think this will be a decade that will probably finish out with automation of some kind. All those pieces are leading up to, and I think you mentioned the next 10 years in this area of voice being able to, because it's tough to have robots if they can't understand us. You
Yeah.
know, they're super annoying. Doesn't matter if they can put your dishes away or clean your house while you're gone or walk the dog. If they can't, if you got to program them, if you got to get on a keyboard to get a robot to work, nobody wants to use that, right? They just want to say it and it's done. So I really do think between now and 2030, we are probably going to see the advent of we got to get voice commands. It has to understand us. It's got to get better at the voice print and understanding who we are. I think we'll first see it in these Amazon devices when they're able to separate our voices, so to speak. I know there's some work, or at least I've heard about some work being done in that area, and pretty exciting. Microsoft's work with Cortana, and of course Google's work with Google Now, or the Google Assistant, all playing. And you got to mention Siri, although it does feel like Apple has kind of quit on Siri. It
Yeah.
hasn't gotten right. It hasn't gotten a lick better in maybe 5 years. It's still, I mean, it's as good. It was cool 5 or 6 years ago. Well, today it's not so cool. A lot of the other assistants have kind of passed it. So I don't know. Maybe we'll see a leap or a jump. But don't you feel like we really got to get voice right? I think the other things will come when we think about mobility, when we think about movement, when we think about being smart or being able to recognize or even have a conversation. That's the other piece, right? Contextual conversations are way behind. There is not a computer in the world that can really have, for the most part, a great conversation like you and I are having right now. That's adaptable, that
Hmm.
is in context, that it adds humor, right? I mean, that's able to be a little dark and then add some light. Those kinds of things machines just we're just not there yet. So I think we got some exciting things ahead.
Yeah.
Christian, anything else that I missed?
No, I mean, I hopefully gave kind of an overview of just like where we are with all the different buzzwords and the technology framework, and that way, when we dig into more specific facets, we at least have some ground truth and common understanding of what we think the terms mean and why. So, no, I think that's a wrap.
I think it's good. We will shoot for 2 weeks from now again for although we're getting into the July time frame. I'm thinking we still might be able to do that. We got some things coming up, but we're going to shoot for every 2 weeks, and so you're going to kind of want to watch the Cyber Frontiers channel as we put these things together and more continued conversation. I think it's hard to separate AI from cybersecurity because I think we're getting smarter with cybersecurity based on AI and machine learning. Don't you think?
Yeah, absolutely. I mean, a lot of the intrusion detection prevention systems and some of the advanced like network threat monitoring, et cetera, are coming from advances in AI and ML being the things that are actually analyzing the traffic and the software and the code. And really, like, what is antivirus becoming? It's becoming like not just signature based, but pretty deep. Like a lot of the antivirus, if you want to be competitive, has to come cooked in with some sort of machine learning engine within it, so that it's looking at heuristics of code and of malware and learning over time what is malicious based on the usage patterns of how the software interacts with the system.
Yeah.
So
it's taking into account global usage, global traffic, what it knows, kind of a deep learning, right? In the sense that it's really taking in multi-factors, not just saying, well, the signature is there,
right.
therefore it must be. And Microsoft is pioneering even where, again, you have a client on the edge that is continually checking back in with the cloud to say, update me, and don't just do it once a day, but maybe once a minute or once a second as things are changing, from a threat. And so I think as we get better bandwidth, as we get better compute, even on the edge, we'll continue to be, have better. Now, I've been using Defender for a while now on some of my PCs, and man, it likes to whack all that mining software.
Yeah.
Even though I tell it not to, it's like, I had to shut it off on one of them because it just kept wiping it out. So,
and I mean, that could be the next big thing with antivirus engines, is figuring out how to throw off their learning models of heuristics and behaviors, such that you send it a bunch of off data points, and then the one thing that it thinks is safe no longer is, because you've skewed what its understanding of malicious is, right?
Yeah. I do think, Christian, as we wrap this, I do think we think when about AI or machine learning that it's a perfect model, right? And when machines won't make mistakes when we train them perfectly. And I think for as many things as right about them, there's always someone who will hack that and make it wrong, right? Just like you said, send it so many false signals that now true is false and false is true.
Yeah, exactly. I mean, that's the most fundamental way to think about it, but you're absolutely right. Yeah.
So I think we've got some, it will never be perfect. What's the amazing thing is in the United States, there's 280,000 automobile accidents every single day. What makes the news is when one autonomous car gets an accident, and you think, hey, humans don't have as good of a record as machines do, but I think we have higher standards, or at least socially, we have a higher standard for machines than we do for ourselves. Don't you think?
Yeah, I'd say that's pretty fair.
They can't be wrong. If they're wrong, they're not worth anything. But yet we're wrong all the time.
Yeah, but we also, again, we expect those superpowers of machines being very exacting in computation and memory to be very precise, because we credit ourselves with being imprecise in part because we're not always super sharp about that kind of thing.
Well, we're biological, right? And that's what makes us great. Also is our weakness. So it's so pretty cool. Well, I'll remind everyone, if you haven't yet, subscribe, rate, and review to this. If you're on an Apple Podcast, that's super easy. You can just do that right there in the app. If you're listening on YouTube, well, if you're on an Android app, you can do that. Whatever, you can figure out how to do that inside whatever you're listening to, Pocket Cast or Overcast or those. If you're listening on YouTube, you want to subscribe to the channel. That way you get notified. And then Ross was in here a little bit earlier. He told me he got the alert notification on Spreaker. If you just head out to Spreaker, subscribe, to put your email in and say, hey, whenever Jim goes live, I want to get an alert. A Spreaker will send you an alert, let you know when we're live. That way you don't have to remember. You might be a few minutes late, but it's a great way to remember and get this in. So get that done. Don't forget theaverageguy.tv, powered again, Maple Grove Partners, secure, reliable, high-speed hosting from people that you know and you trust. For more information, visit maplegrovepartners.com. If you've got questions, you want us to cover something, you want to throw something out to Christian, send him an email, christian@theaverageguy.tv. Bless you. You can also send me an email, jim@theaverageguy.tv. Computers don't sneeze. I don't know why they don't, but they don't.
And computers are smart enough to hit the mute microphone button and stuff like that happens.
It's closer to them. They're non-biological, right? And track me down on Twitter @JCollison. Of course, Christian is @BoardWhisperer. We hope you enjoyed it. We'll be back for another Cyber Frontiers here in a couple weeks. With that, we'll say goodbye.
Good night.